Welcome to ilectureonline. In this video, we're going to start some examples on how to find the distributed loads on beams. Here we have a theoretical example where we have a beam which is supported at A at one end, at B on the other end, and we have variable forces acting on the beam. You can see that there's less force per unit length here, there's much more force per unit length there. And so how do we find the reactionary force at A and how do we find the reactionary force at B? In some cases, a moment is created and then we also have to find the moment about some point. The way this can be done, since this is the chapter where we talk about the center of mass and the centroid, the way this can be done is to find where the centroid of the forces acting on the beam is actually located. In other words, what we can do here is we can take a small segment, calculate the force acting on the beam on that small segment, and then the centroid in the x direction, of course, would be right there. That would be the centroid relative to the, let's say, from point A to that particular point. Let's call that the centroid of that small little force. So that's a small df acting at a distance x away from point A. And then we find the force right next to that, and again we find the centroid there, and the force next to that, and centroid there. If we add them all up for the whole beam and divide it by the total force acting on the beam, we can then actually find the centroid. So the concept here is that the centroid for all the forces combined is equal to the sum of all the small little forces, let's call them small little df's, times the centroid of each of the df's divided by the total sum of all the forces, and that gives us the location of the centroid where all the forces are acting on the beam. Let's assume that the centroid is right about here. I would assume that it's a little bit past the halfway point because it looks like there's more force acting on the beam on the right side than on the left side. This would be the centroid of the forces. Why that is important, finding the centroid, is because at that point it acts like all the force is acting on the beam at that particular location. If we draw a force vector here, call this force total, that would be the total force equivalent to all the force acting on the beam in its entirety, as if it was concentrated at that one single point. And once we do that, we can then put a pivot point right there, sum up all the moments caused by the total force acting at the centroid and the reactionary force at B to find the reactionary force at B. Then we can move our point right here, do the same exercise, find the moment about point B by using the total force acting through the centroid, and then we can find the force at point A. That's a very slick technique, and it works because we can find the centroid of all the forces acting on the beam, which means that it appears as if all the force acting at that single particular point. With a few examples which are coming up, you can see how that's actually a very easy, clever technique to use, and that's an easy technique to use to find the reactionary forces at A and at B, or whatever the support points are, and also any moments that can be created if the beam is, for example, supplanted inside another structure so that it's hanging on one side, and we then see a bunch of force acting on the beam, again variable force, and then we have to find out what the moments are, what the total force, the reactionary forces are. It all comes down to taking distributed loads and concentrating them at one single location at the centroid. And then the problems will become a lot easier to deal with. So if you like this kind of thing or you're interested in finding out how to work these, stay tuned and we have some good examples for you coming up.